All right, so this is a key to topic 24, radicals, extra 19. And remember, topic 24 is where you're solving, and we're only dealing with square roots here, so where you're solving these square root equations. So let's look at number one. So number one, we have the square root of 3x minus 2 is equal to 4. Now remember, when solving a radical equation, you have to get the radical by itself, and it is. So the square root's already on the side by itself. And so once you get to that point, remember, I'm going to go ahead and rewrite this over. Once you get to that point, the next step is to get rid of that radical symbol. So to get rid of the radical symbol in an equation, see the index is 2. So the way to get rid of the radical symbol is to raise both sides to a power equal to the index. Well, if the index is 2, that means you're going to square both sides. And so now the square and the square root undo each other. So you get 3x minus 2 is equal to, and then 4 times 4 is 16. So notice I went from this square root equation to a linear equation. And so I'm just going to add 2 to both sides. And so I get 3x is equal to 18. Divide both sides by 3. I get x to be 6. Okay? All right, now remember one of the other things that you learned was that when you raise both sides to an even power, you may introduce extraneous solutions. So you really should check. And that's going to be important in the next lesson, on the next worksheet. But go ahead and let's check this. So let's check to make sure that x equals 6 actually works. That is, it is a solution. It's not an extraneous solution. So always go back to the original. So here's my original right here. And so wherever you see the variable x, I'm going to substitute 6. So I get the square root of 3 times 6 minus 2. And I want to see that's going to equal 4. Well, 3 times 6 is 18. And 18 minus 2 is the square root of 16, which does equal 4. All right, so this works. This is not an extraneous solution. Number 2, we have the square root of 2x plus 5 minus 3 equal 1. So remember, when we talked about number 1, the idea is to get the radical by itself first before raising both sides to a power equal to the index. So here, the square root's not by itself. I have to subtract 3 right here. So we're going to add 3 to both sides first. And I get the square root of 2x plus 5 is equal to 4. Now, since the radical is by itself, I want to get rid of that square root symbol. So the next step, remember, is to raise both sides to a power equal to the index. And so when I do that, I didn't realize I'd get 16 again, but we got 16 again. The square and the square root undo each other, so you get 2x plus 5 is equal to 16. All right, so now notice I went from the square root equation to a linear equation. And I did raise both sides to even power, so you may have introduced a solution that's not a solution to the original problem. So you need to check to see if what you end up with actually is a solution. So let's go ahead and subtract 5 from both sides. So I get 2x equal 11. So x is 11 halves. Okay, oops, 11 halves. So let's go ahead and check to make sure that actually works. So go back to the original. Here's your original. The square root of 2x plus 5, subtract 3 equal 1. And so in place of x, I'm going to substitute 11 halves. So notice what we get. We get the square root of 2 times 11 halves plus 5, and then subtract 3, and you want to see that's going to equal 1. Well, 2 times 11 halves, the 2's divide out, so that's just 11. So this becomes 11 plus 5 minus 3, and you want to see that's going to equal 1, right? Well, 11 plus 5 is 16, right? So I get the square root of 16 minus 3. Well, the square root of 16 is 4, and is 4 minus 3 equal to 1? The answer is yes. So x equal 11 halves is a solution. Number 3. So number 3, we have this for number 3. The square root of 2 minus 3x plus 2 is equal to 7. So again, just like with the previous problems, you need to make sure when solving a radical equation that the radical term is by itself. So I got to get rid of this 2 right here. Well, the opposite of adding 2 is to subtract 2. So then I get the square root of 2 minus 3x is equal to 5. Now, remember, to get rid of that square root symbol, I'm going to raise both sides to a power equal to the index. Well, the index is 2, so I'm going to square both sides. And so when I square both sides, the square and the square root into each other, so you get 2 minus 3x is equal to 5, right? Then let's go ahead so notice I went from a square root equation to a linear. So let's go ahead and subtract 2 from both sides. So I get negative 3x equal to 3. Divide both sides by negative 3. I get x to be a negative 1. Okay, so let's check it. So always go back and you check this, because I raised both sides to even power, so I couldn't introduce extraneous solutions, so false solutions. So notice that x equal negative 1 is a solution to the linear, but the question is it a solution to this square root equation? So let's check x equal negative 1. So let's go ahead and rewrite the original problem. Always go back to the original. 2 minus 3x plus 2 equal 7. So in place of x, I'm substitute negative 1. Now be careful. So this becomes square root of 2 minus 3 times negative 1, just like this. Notice I put negative 1 in parentheses. Whatever that is, I'm going to add 2. I want to see if that's going to equal 7. Well, let's simplify this radicand. So in terms of this square root term, I have 2, a negative 3 times a negative 1 is a positive 3. Okay? And so plus 2 I need to make sure I did this correctly. Let's see. Let me do this again, because it's not looking like see that's a 5 here, and the square root of 5 plus 2 is not equal to 7. But I think that is a solution. So let me just double check one more time. Oops, here's where I made a mistake. 5 squared is not 5. What's 5 squared? 25. So that becomes 23, right? So negative 23. Let's see. Let's do this again. Square both sides. So I get 25. 25 subtract 2 is 23. So I get negative 23 thirds. Okay. So x equal negative 23 thirds. Let's check it. Negative 23 thirds. So in place of x, you substitute negative 23 thirds. And you see, I knew something was wrong, because I knew that was that this was going to work, but it wasn't working out here. Okay, so I want you to think about this. Now notice, see this right here? You have this. You have negative 3 times a negative 23 thirds. Well, the 3's divide out, and so you have a negative 1 times a negative 23, which is a positive 23. And so this becomes 2 plus 23. That's 23 right here. Well, 2 plus 23 is 25. So the square root of 25 plus 2 is what you have on this side. I want to see if that's going to equal 7, right? Well, the square root of 25 is 5, and 5 plus 2 does equal 7. All right. Well, sorry about that. I forgot about for some reason I said 5 squared is 5, and it should have been 25. All right, and so that is number 3. Okay, so let's look at number 4. Number 4, we have this for number 4. We have 7 plus the square root of x minus 8 is equal to 10. So again, we need to get the radical by itself. So let's go ahead and subtract 7 from both sides. And so 7 minus 7 is 0. So all you're left with is the square root of x minus 8 equal 3. So now to get rid of that square root symbol, I'm going to raise both sides to a power equal to the index. So the index of square root is 2. I'm going to square both sides. And so the square and the square root into each other, so get x minus 8 is equal to 9. 3 times 3 is 9. Adding 8 to both sides, I get x to be 17. Okay. Now remember, I raised both sides to a power equal to the index, so I should check this. So let's check x equal 17. Always go back to the original. 7 plus the square root of x minus 8 equal 10. So in place of x, I'm going to substitute 17. So I get 7 plus the square root of 17 minus 8. And I want to see how that's going to equal 10. Well, 17 minus 8, so I get 7 plus the square root. 17 minus 8 is 9, right? And then, so I get 7 plus, and the square root of 9 is 3, and 7 plus 3 does equal 10. So that's your solution. All right. So that is the key to topic 24, radicals, extra 19.